Hello everyone and welcome back to my channel. Sorry for my weird voice, but I have a nasty cold due to which my nose is currently malfunctioning, but it will pass in a few days, so please ignore it. Today on the bench, I have a power supply to repair. 5 volts, 40 amps. Or at least that's how they say. That's what they say. It failed and I have been asked to take a look at it. Seems to have been physically damaged. The upper case is bent. Hopefully nothing is damaged inside. So let's open it up and see what could be wrong with it. Some signs of overheating here on the board, but I guess it's normal with these Chinese power supplies. Yeah, bulge capacitor. So what do we have here? Some heatsink for the diodes, I guess. Yes, this should be the diodes in the secondary side. This is the output inductor, series inductor, needed for regulating the voltage. A beefy minus 52 core. Something is moving around inside. Where is this from? Ah, yes, from the power transformer. The case was bent and broke this side. But this shouldn't be a problem. Let's take out the board. This capacitor tells me that this supply should be a half bridge configuration. It's usually in series with the primary side of the transformer. And these 200 volts capacitors, Nichicon, wow, confirms that. They should be in series, and this cap should be in series with the primary coil. So yeah. No nasty surprises on the bottom side of the board. Some corrosion here, but nothing too serious. More corrosion here. This is not good. Humidity is always bad for a switching power supply, especially mains powered supplies. Yes, this capacitor indeed is in series with the primary coil. Yes, and these capacitors are in series, of course. Bridge rectifier, EMI filtering, some inrush current limiting, X2 capacitor, no Y2 caps, Doesn't seem to be. No, they should have been here. These two. Fuse, mains filtering caps, some snubbering, I guess. Yes, snubbering resistors, together with this blue capacitor, the power transistor, BJTs, yes, 1309009, yes, BJTs, not MOSFETs, and this is the driver transformer. This should be the common layout for the cheap ATX power supplies. They too use BJTs, and this arrangement on the driver transformer, and this should be 494, right? 7500, same IC. And these diodes, come on, focus. SBL3040PT, Schottky diodes, common cathode, 30 volts, 40 amps, or rather the other way around, 30 amps and 40 volts, something like that. Let's do some measurements, right? First, the fuse. I know it's on the diode, but if it beeps, it is good. It is good. Wow. Then why did the owner said it isn't working? Maybe due to these caps. Still, let's measure everything we can. So the bridge rectifier, all four diodes are okay. The BJTs, base collector emitter, NPM, NPN, both of them. How come the BJTs are shorted but the fuse is intact? I don't get it. Is this NTC open? No, it is not. And I am confirming that the fuse is okay. How? Something must have gave up because this power transistor short the mains. Or do they? Only one of them seems to be shorted between the collector and the emitter. Yes, so this is why the fuse didn't blow up. This is the shorted transistor, and the emitter goes right to the minus side of the high voltage, and its collector goes to the emitter of the other one, of the upper transistor, and it goes to the driver transformer, and through a one-turn winding in the driver transformer goes via this wire here on the other side of the primary coil on the main transformer. So let's see, do I have continuity? It needs to be, yes. If I had an open circuit here, it would have meant that the driver transformer failed, but it didn't. Let's see the secondary side rectifier diodes. They seem to be in parallel, their cathodes. Yes, through this jumper wire here, and it seems to be a center tap secondary. So let's see. On the diode function, of course. Are they shorted? No, they're not. They are Schottky diodes, so they have a very low forward voltage. Let's see the capacitors. I'm using this analyzer. So the mains filtering caps, 470 microfarads each. $277, kind of on the low side. 292. So they're not Nichicon. I doubt true Nichicon caps would fail to meet their capacity so badly. But anyways, the output caps, I won't even bother measuring them. One of them is bulged. I will replace all of them. Let's see these small ones. They often fail. 4.7 microfarads, 50 volts. Nothing. I told you. Or is it? Yes, this is it. This capacitor makes sure turning off of the BJTs is faster. They charge on the turning on phase, and then on the turning off they discharge with a reverse voltage on the base emitter junction, so they make sure that the BJTs turn off faster. This one has also failed, completely failed. They have here the same job they have in the cheap Chinese ATX power supplies. Another capacitor here. This should be 10 microfarads. It usually is. How about this one? No, 4.7. Budget cuts, right? 3.4, 8 ohms. So we do have a few capacitors to replace. Another 4.7 microfarads. This one, yeah, this one should do the soft start part of the power supply. Or is it? No, it filters the voltage reference of the IC. Not with the multimeter. 29 ohms, 1.7 microfarads. Wow. One microfarad. Yes, this one takes care of the soft start function. 1 microfarad, 50 volts. Of course it's dead. Why shouldn't it be? I don't remember ever encountering a power supply with so many failed capacitors. 22 microfarads, 50 volts. A bit higher, a bit high on the ESR rating. It filters this IC power supply. Yes. No, I was wrong. I had a look on the board, and this is not the filtering for the power supply for the controller IC. This capacitor is part of the protection circuitry. This one does the filtering part. So let's see. 29 microfarads and 0.9 ohms. Out of what? 50 volts and 47 microfarads. So this one is also almost dead. So we do have some work. All the electrolytic caps. I'll try and find these ones as well. Even if they are not new. All the others need to be replaced. And these transistors. So yeah, let's get to work. Because I do not have any new replacement for these capacitors, I want to first take them out and measure them off the board to make sure it's not something that interfere with the measurement on the board. So let's see. First, make sure they are discharged. (290 microfarads), 277 microfarads, a bit low if you ask me. They should be 470 microfarads. Granted, what, 20%? I do have these used caps on capacitors. They should be okay. They are 560 microfarads and 200 volts. (472 microfarads). This one, 495, 96 microfarads. Both of them under 100 milliohms. So yeah, these two should be much better, even though they are not new. So I'll use them. These will be the output capacitors. 2200 microfarads, 16 volts, Jamicon, low ESR caps, yep. This is the replacement, 47 microfarads, 50 volts. This one is at 63 volts. I also have a new 22 microfarads capacitor. Remember the one on the board had almost 5 ohms on the ESR. This one just over 500 milliohms, so much better. This is the replacement capacitor for the 1 microfarad one. This one is a 2.2 microfarads, but it's no bad thing. All it does is increase in the soft start time. And these are 10 microfarads, 50 volts for all the other caps. The ones that on the board are 4.7 microfarads. They should really be 10 microfarads. And also, I do not have any new spare BJTs. I am mostly working with MOSFETs, but I do have good used ones. I have a box full of them. These are from Fairchild. And look, come on. Just about the same. So let's get to work, right? All the capacitors are replaced with new ones, except of course for these ones, but they measure okay. Now for the transistors. These are the dead caps.
Feel like taking over.
The upper BJT had only its base shorted to its collector, but the lower one was shorted all the way. 'Cause I just can't stay here, stagnant under pressure. Before I put the replacement transistor on the board, let's check the base network. Let me guide you, 'cause there ain't no way. Feel the pressure of the outside. Feel like taking over. 'Cause there ain't no way. Let me guide you till we find no way. It is a good thing I did, because as you have seen, this resistor is blown up, is open. Yes, it is. I will replace them both, just to make sure. All the other components seem to be okay. Measure okay. I am using 2.2 ohms resistors, just because I don't have any 1.5 ohms resistor at the moment. Through hole resistor, that is. I am usually mostly working with SMD parts. All the parts are in their place. I have cleaned up the board. Now let's put it back in the case. I am not using thermal paste at the moment, just in case the power supply it's still not working and I have to open it up again. For now, I just want to test it. And these seal pads should be quite enough. I am now ready to test the power supply. I am connecting it to the mains. I have my LED and no boom. Do I have an output? Yes, 5 volts. Pretty much spot on. I want to test it under load, and I am using my electronic load. This thing doesn't go to 40 amps, it only goes up to 20 amps maximum current, but I'm not going even there. I have a 40 amps electronic load kit, but I haven't got to the assembly part yet. Let's power it up again. So I do have my 5 volts output. I am testing it at 15 amps. It should be okay, just to confirm that the power supply it is working. So let's start the test. 4.94 volts on the electronic side, on the electronic load side at 15 amps. The power supply output stays at 5 volts. I want to take a look at the power supply with my thermal camera. Nothing suspiciously hot. So the power supply it is working. this part seems to have stretched a bit, so I'm not able to straighten it out very well. I'll leave it as it is. Right, the power supply, it is back in its case. And let's test it one more time to make sure it still works. So I do have my LED. Do I have my 5 volts output? Yes, I do. So this is it. And this is my video. The power supply, it's fixed. So yay, victory, right? As I like to say. So I am ending my video now. If you watched it until the end, thank you very much. If you liked it, please give it a big thumbs up, subscribe, and all that YouTube stuff. If you like my channel and you want to support me, you can do so by buying super thanks or by joining my channel. So thanks for watching. See you next time. Bye.